In this example, we're told 500 students are studying mathematics courses at Flinders University. So, mathematics courses at Flinders University, there are 500 students. So that is the whole population. On a recent exam, the mean score was 67.2. The standard deviation was 17. So our population, the total number of students doing mathematics at Flinders University, is 500. On an exam, their mean score was 67.2. Their standard deviation of their scores was 17. So in part A, it says to us, sample of size 5. In other words, we're taking a sample of 5 of those 500 students. So that is going to give us the value of n. N is equal to 5. Are selected and the means are found. So taking out groups of 5 and finding the means. Find the mean and standard deviation of the distribution of the sample means. Earlier, we were told the expected value of the sample mean was equal to mu. We were told mu in the question was 67.2. We're then asked to find the standard deviation. To find the standard deviation, we're going to use the standard deviation of x equals the variance of x. So we need to calculate the variance of the means of x. Now, we had for that standard deviation squared of the population divided by n. The population standard deviation was 17. So we've got 17 squared over our sample size n, which was 5. Working that out on my calculator, I get 57.8 to 1 decimal place. To work out the standard deviation of the sample means, I take the square root of the variance of the sample means, which was 57.8, to 1 decimal place. That gives me 7.6. In part A, we had very small sample sizes, sample size of 5. In part B, it says to us if the sample size was increased to 30. So this time we've got n is equal to 30. What effect would this have on the mean and standard deviation of the distribution of sample means? So our sample mean, the expected value of the sample mean, is still equal to mu. We were given that as a definition. So that is still 67.2. So my sample means have stayed the same when n was 5 and when n was 30. Now if we consider the variance, this will be different because we have the population standard deviation squared over the sample. The sample n has increased. This sample size has got bigger. So that we're going to have 17 squared over 30, which gives us 9.63 to 2 decimal places. So we can see the variance is much smaller. So the standard deviation of our sample mean is equal to the square root of the variance of our sample means. That is the square root of 9.63, which is about 3.1 to 1 decimal place, not 73.1.